Our last one uses completing the square. What? That's like forever ago, if you even learned it. So completing the square basically is what we're trying to do. This is not a perfect square right now. I can't factor this into a perfect square, and I want it to be a perfect square because I want it to be in the form 1 over 1 plus u squared, because I want to be able to do tangent, arctangent. So we're going to use completing the square so that we can get something squared right here and then use arctangent. Okay, so first things first, let's complete this square. So x squared plus 4x plus 8. If you remember, to complete the square, we take this middle term b and we divide it by 2, which is 2. And then we square it, which is 4. And what we do with that amount is we add it and we subtract it from our original equation here, our original expression, because if I add it and subtract it, that's basically like adding 0, which is totally legal in math. And now what I'm going to do is I'm going to move these things around so that I can make a square, okay? So I have x squared plus 4x plus 4, right? I took this 4 and I bring it over here, and then that is going to be then plus 8 minus 4. So I'm going to have x squared plus 4x plus 4 plus 4. And you see that that is literally the same thing as I had here. It's just written a little differently. Now, what is this factored? Well, it's x plus 2 squared and then plus 4, right? So this I can rewrite as this. Okay, so we're going to write right here the integral of 1 over x plus 2 squared plus 4 dx. Okay, because that's just rewritten like that. All right. Now it's really, really close to this form, right? It's really close because it's almost 1 plus u squared, but it's not, right? So this is u, x plus 2 is u, so we're good. But it's 4 plus u squared. So we got to do a little bit of manipulation here. And we're going to divide both of these by 4 and bring that 4 outside the parentheses. Okay, so we're going to bring our 4 out here so that now that's, instead of being a 4, that's going to be a 1. So we have 1 over, and then we have a 4 outside, right? And then we have x plus 2 squared over 4 plus 1 dx. All right. So now, since this is 4 is a constant, I can just bring it outside the integral like that. And I have 1 over x plus 2 squared over 4 plus 1. So again, I'm like super, super close, but this isn't one whole quantity squared. It's x plus 2 squared over 4. So let's make this squared, right? Because if I had x plus 2 squared over 4, isn't that the same as x plus 2 over 2? And all of it squared, right? Because that would square the top and it would square the bottom. So these two are equal. So let's rewrite that. We're going to have that equals 1/4 1 over x plus 2 over 2 squared plus 1. Okay, we are finally in the format that we wanted, which is 1 over 1 plus u squared, right? Okay, because this is 1 over something squared plus 1. Okay, so now, not du yet, dx. Now we can do a u substitution. Okay, u equals x plus 2 over 2. So therefore du equals 1/2 dx, because really that's the same as 1/2 x plus 1, right? And so, all right. We got this. We're in calculus. I don't need to explain that, do I? Maybe. 2 du. That's okay if I do. All right. So we can just replace this. We can do a u substitution, and we get 1/4 times the integral of 1 over u squared plus 1 times 2 du. And we're going to bring that 2 outside. So now we have 2/4, which is 1/2, times the integral of 1 over u squared plus 1 du. Okay, finally, I have the exact thing that I need for arctangent, okay? So now this is 1/2 arctan of u plus c. And I know what u is, right? U is x plus 2 over 2. So I can replace that with 1/2 arctan of x plus 2 over 2 plus c.